So 7.4 talks about solving quadratic equations, functions, and zeros and their models. A quadratic equation is going to be this equation that is in this form. F of x is equal to a times x squared plus b times x plus c whenever a is not equal to 0. Okay, so basically you're looking for something that has the highest power of an exponent as a 2. So an x squared has to be in there somewhere. If an x to the third is in there, now you've gone from something that's quadratic to something that's cubic. Okay, so that really gives your indication that you're dealing with a quadratic. When your x or whatever variable they're using, the highest power exponent is going to be an x squared. When you look at a graph of a quadratic and you're trying to solve it, what you're looking for are the x-intercepts. Okay, so we are looking for x-intercepts. X-intercepts are simply where does the graph cross the x-axis. There are some other words that we kind of talk about that have to do with x-intercepts. Sometimes they call them zeros and sometimes they'll call them roots. Okay, that they just mean the same thing. But if it asks you for the intercept, it wants the whole coordinate. If it asks you for the 0 or the root, it's wanting the actual number. And we'll talk about the difference here in just a minute. So this one actually has 2 x-intercepts. If we were to go to our calculator and type in x squared minus 3x minus 4, we would have 2 answers because it crosses the x-axis twice. So when it asks for the x-intercepts, you would actually list out the points, the coordinates, -1, 0, and 4, 0. But if it asks for the roots or the zeros, you're going to say -1 and 4. You don't put them as a coordinate point. You just say it happens when x is -1 and 4. Does that make sense? But if it's specific, it says the intercepts, then you're going to want to list out the whole coordinate point. So this one has 2 because it crosses the x-axis twice. And I would say a lot of them have that, are going to cross it twice. This one, x squared minus 6x plus 9, only crosses the x-axis once. So its x-intercept is this point, 3, 0. And if we want to talk about the roots or the zeros of this one, you would just say that it is 3. Why is that one like that? If I were to factor this and say what multiplies to 9 and adds to -6, right? What multiplies to 9 and adds to -6, you would say -3 times -3. And so this would be x minus 3 times x minus 3 when we factor it. And since both of those are the same, we would just have x minus 3 squared. That's why we only have one root, because when we solve this thing for 0, we would just get x equals 3, but it happens twice in our equation, but that's why we get that. This one right here, x-intercepts and roots and zeros, well, we would just say all of those things are none. We don't have any because it never crosses the x-axis, okay? Why doesn't it ever cross the x-axis? Are there no answers to this problem? There are, they just can't be represented on the graph because they're imaginary. And we've talked about this just a little bit, but when you're solving x squared plus 13 equals 0, you would subtract 13. And so you would get x squared is equal to -13. We talked about the way that you get rid of a squared is to take the square root. And when you try to take the square root in the calculator, it's going to say, you can't do that, right? Because it's an imaginary number, and we would have a plus or a minus. Taking the square root of a 13, we would pull this I out front. We'll talk about this a little bit more in a minute, but we pull an I out front to represent that negative, and then we leave our square root of 13 underneath. In just a minute, we're going to talk about why there's a plus or minus, okay? But So I'll go over that part and the I part in just a minute. Okay, is everybody good with this so far? So given a graph, you should be able to look and tell what the roots are. It's where it crosses the x-axis. Okay, so when we're solving these, there are 5 different strategies that we could use. And I'm going to show you some more about the calculator strategies in a minute. We're fixing to go over these strategies right now. So example 1 is going to be strategy 1. Example 2, strategy 2. Okay, so I could read all of this to you guys, but it would be like painful. So I'm not going to do that. This one we kind of already talked about. We said that you can look at the graph and you can tell what the x-intercepts are by the places that cross the x-axis. So our x-intercepts, one of them would be -1, 0. And the other one would be 3/2, 0. But if we want to just talk about the zeros of the function, well, they're at x is -1 and 3/2. We want to talk about the roots, -1, 3/2. Okay. So the second way that we can solve these is by factoring. We've done a little bit of factoring in this class, but not a lot. So this is one of those things that I hate saying this as a teacher because it drives me crazy. You're supposed to come here knowing some of this. So I am going to go over it, but that is kind of what the lab part of it is for this, for College Algebra with Support. If you need extra help with factoring and you want to know how to do it, we can work on it more in there because it really is time consuming to go over everything about it. Okay. It would be like 3 weeks of classes trying to teach you guys how to factor efficiently if you didn't know how to do it already. Okay, so if we solve these by factoring, the first thing you're going to have to do is you're going to have to let this thing solve it and let it be equal to 0. So I've got 2x squared minus x. And then to get this to equal 0, I would need to subtract 3 from both sides. So I would end up with -3 equals 0. So 2x squared minus x minus 3 is equal to 0. When they say to factor it, what they're asking you to do or solve by factoring is they're asking you to split this back up into the, I guess, unfoil it is what we would say, because when we would do that first, outer, inner, last, now we're going backwards. So when there's something in front of the x, a strategy that I like to use is I draw a box. I'm sure that you guys maybe had some teachers that had different strategies about this. If I'm having to do this in my brain, I don't have a calculator. This is one of the strategies I use. I draw a box. I write this first number, 2x squared, in this first box. And I write my last number in the one diagonal to it. Okay, so that's all I've done so far. I put the first one in the top corner, put the last one in that bottom right corner. Then I tell myself, these 2 boxes right here, well, they are going to have to add to be whatever this middle box is that I didn't mess with. They're going to have to add to give me a -x, which is the same as -1x, right? So whatever I get in these 2 boxes is going to have to add to be -1x. So how do I work from here? I think about things that multiply to give me 2x squared. There's not a lot of things that multiply to get me 2x squared. I could do 2x times an x. So I'm kind of thinking about this as being like a multiplication box. So 2x times x would give me 2x squared. That would be an acceptable thing to put there. Then when I go and look at -3, and this is kind of like one of those Sudoku or however you say that puzzles, you have to kind of brainstorm about this. It's not just something that there's an automatic answer you put there. Okay, so when I look at -3, I think, well, what kind of things multiply to give me -3? 3 and -1 or -3 and 1, right? Whatever goes here and here have to multiply to give me -3. So I got to try something. I'm going to try -1 and 3. I might have to erase it, but I know that 3 times -1 does equal -3. So I've at least got these boxes correct. Now I want to see if what I did is going to answer the question to these two boxes. So to get this, I'm going to say, well, what is 2x times -1? 2x times -1 is -2x. Is everybody okay with that? Then I would go, well, how am I going to get this one? I'm going to have to match these and say, well, this is x times 3. Well, x times 3 is just 3x. If those two add together to get me -1x, I'm done. I can write my answer, but unfortunately 3x plus a -2x is +1x, right? 3x plus a -2x would be a +1x. So I'm gonna have to switch something. Anybody have any ideas of what I'm, and the things on the outside are what I can switch. Maybe if we make this be negative, if I make that be -3, then I'm gonna have to make this one be a +1 because -3 times +1 still has to give me a -3 here. Okay, I'm gonna go and make sure. So I'm gonna say now 2x times 1 just gives me a 2x. And this one, x times -3, well, now I've got -3x. Do those two add together to get me a -1x? -3x and 2x? Yeah, -3 plus 2, -3x plus 2x would get me a -1x. So I'm done. The answers are what's on the outside right here. So I could write down 2x minus 3. And then I would write down this part. And since we don't usually put the positive sign if the number is positive, but so if it's a +1, we're going to put x plus 1 there. Okay, if I FOIL that out and say that first, outer, inner, last, I would get back with what I started with. So do not get super stressed out about this because I'm going to teach you a way to do this on the calculator. Okay. And if you don't have a graphing calculator, there's a way that you can do this on the computer as well. But the way that you finish this is you set them both equal to 0 and then you solve that. So we would add 3. We would get 2x is equal to 3, divide by 2. So one of our answers is x equals 3/2. And on this one, we would subtract 1. So we would get x is equal to -1. So looks like it's the same as the problem above, right? We just have the equation now and we solved it by factoring instead of solving it by graphing. So our x-intercepts would be -1, 0 and 3/2, 0. Okay. Questions about that? When you have this one, when I see this example right here, this is actually makes me happy because I think, man, this is easy to solve algebraically. And that's what I would do. I would go to this problem and say, this one is a little bit different because it does have the x squared, but usually there's an x squared and then an x, regular x, and then a number. And this one is missing that regular x. So even when you have a calculator, it's easier just to solve this one. Just use algebra and solve it for x. If it's missing the x in the middle. Kind of like this one. See, this has a 2x here. This one has a 5x. This one doesn't have an x. That's what I mean. It's missing the x. So what you would do is just say, well, I need to get x by itself. So I would add 10 to both sides of my equal sign. That's going to get me 2x squared is equal to 10. Divide by 2. Divide by 2. These 2's are going to cancel out. And I'm going to get x squared is equal to 10 divided by 2, which is 5. To get rid of the squared, you have to take the square root of both sides. And so the final answer would be x is equal to plus or minus the square root of 5. Okay. before we go any further with that, let's talk about this plus or minus business, okay? I don't want to be one of those teachers that says, if it's a square root, it's plus or minus, just do it, okay? I want you to at least have a clue of why you're doing it. So probably somewhere along the way, I would say probably 7th grade math, you probably started talking about what a square root was. And you knew that you were looking for two numbers that were exactly the same, that if you multiplied those two numbers together, you would get back whatever was underneath the square root. And so the square root of 4 is equal to 2, because 2 times 2 is 4, right? You can kind of understand that. But, and forever, they probably said, you know, just you accepted that because you didn't know any better or didn't know any different. And probably about 10th grade, they started saying, but wait a minute, the square root of 4 can also be -2, because -2 times -2, a negative times a negative is also positive. And so those two numbers are the same and they multiply to get together to get you 4. So that's why the square root of 4 could be plus a +2, or it could be -2. And that's how people write plus or minus 2. So when you take the square root, there's always 2 answers, unless it's the square root of 0 and you can't do a plus or minus 0. But that is why, because there's 2, there could be the negative times a negative that would get you a positive. Everybody okay with that part? Another thing that I don't have a lot of time to talk about it right now, but I do need you to understand, or at least try to wrap your mind around the concept that if you take the square root of a negative, that it is imaginary. And this is, so the square root of -1 is I. That is just a definition. It's a definition that's the same as saying, I guess this is a symbol that represents what the square root of -1 is. It's the same thing as simplifying something. So if I wrote down a fraction and I said, don't write this down, but if I wrote down 4/8, well, you'd say, well, that's 1/2. Okay. Square root of -1 is just also written as I, and that's the simplified version. And we're fixing to come into some of those. Okay. So before we talked about what the square root of -13 was in the problem on the previous page. And I said, just for right now, accept that this is I times plus or minus I times the square root of 13. We get the plus or minus part from this. -13 is the same thing as saying -1 times 13. So plus or minus the square root of 1 times the square root of 13. I'm just kind of breaking this down so you can see, well, this is where the I is coming from. And then we've got the square root of 13. Okay, so that would be the answer. Are y'all okay with that? So if, let's just do one more. If I write down the square root of 16, no. Let's do the square root of -16. Well, you guys would tell me that that is, what you should see is that that's -1, and then 16 is 4 times 4. So the answer would be I from the square root of -1, and then the 4. And most of the time people would write the 4 in the front and the I in the back. Okay, is everybody okay with that? So if it won't simplify like 13, you would leave it under the square root. But if you can simplify it, you would pull this out front. Okay. And I'm never going to ask you to do one of these problems like the long way. So you should be able, like, those of you who brought a calculator, I'm going to show you some tools for this when we start talking about support in a minute. Okay. So sometimes we can't factor the problem to find the answer. It's not as easy as just what multiplies to this and adds to this, because it ends up being decimal answers like X is 2.35764, okay? And it won't ever work out. And when that happens, the quadratic formula is what you use. We do have a program on the calculator that does some of this work for you. So, but you would start the problem just like you would start any other quadratic. We would need this to be equal to 0. So I would subtract 7 from both sides. 3x squared plus 2x minus 7 is equal to 0. That's going to be your first step, is you want it to be equal to 0. The next step is you need to compare it to like a generic quadratic that we talked about on the first page. Ax squared plus bx plus c is equal to 0. Because in order to use this formula, this nice pretty formula up here, you have to be able to figure out what b is and what a is and what c is, because those letters are in the formula. So a would be whatever is in front of your x squared. So a in this instance is 3. B is whatever is in front of your x term. So it is 2. C is whatever your number is that doesn't have a variable, your constant term out here. So it's -7. Okay, so we are plugging this stuff in. -b, I'm just writing it so that we can kind of compare it to this. This is our quadratic formula. If we solve this, it tells us the answer. So there's a negative in our formula, so I would put negative. There's a b in our formula, and we said b is 2. When I plug something in, I like to put it in parentheses because it helps me from making mistakes. Plus or minus came from the fact that there are 2 answers to every quadratic. Now we've got this b squared minus 4ac. So we knew b is 2. Then the next thing in the formula is -4. And then we're supposed to plug in an a and a c. A we said was 3. C is -7. All over 2 times a, and a is 3. Okay, at this point, people are like either confused about how we set that up, or they're like, now how in the world am I going to do what the next step is? Is everybody okay with the numbers that we plugged in and where we came up with those? Anybody have questions about that part? If I'm doing this by hand, then I don't want to plug all of this up in the calculator at one time. I will make a mistake. Some of you may be super talented at working the calculator, but that is too much for me to try to get in. So what I would do is kind of break this up into steps. So -2 plus or minus the square root. Now the calculator can handle this part, this 2 squared minus 4 times 3 times -7. I could plug all that in, and it would give me the answer is 88. If I plug that in the calculator, still a square root of 88, all over 2 times 3, which is 6. Everybody good up until now? Okay, now this is another step that should have came to you before you got to me, and that's reducing a radical. A radical is just a fancy name for square root. So if I were to go type in the square root of 88 in the calculator, it's going to give me some kind of decimal. And that's not what we want here, because we want the exact answer. So when I say, if it gave me 2.3, that would be great, but it's going to give me like 2.3576, and it's never going to end. So it's a non-terminating or repeating decimal. So I need to know the exact answer. So I actually have to look at, well, what is 88 made of? Is there anything that I can, so we know if we take the square root of, remember, if we take the square root of 4, we would get 2. What I'm trying to do with that is the same thing down here. So what you would do is you would look at the factors of 88, the prime factors of 88. So 2 is a prime number, and it'll go into 88 44 times. And I'm going to keep using 2 until I can't use it anymore. 2 will go into 44 22 times. 2 will go again into 22, 11 times. I can stop right there because 11 is prime, can't move any farther. So if there is a pair of something, that gets to be pulled on the outside of the square root, and whatever is left stays underneath the square root. So I'm going to simplify this just a little bit. I'm getting this -2 from here, going to write plus or minus. Now let's talk about the square root of 88. We said we had a pair of 2's that gets to come out front. The 2 times 11, which is left, would stay underneath the square root, and 2 times 11 is 22. That's where I'm coming up with that from. And we're doing all of that over 6. We haven't messed with that. The very last step is to look at each individual term. So the -2 and this 2, I'm not going to worry about the square root part, and this 6, and go, is there anything I could divide those 3 things by that would come out even? Similar to if I wanted to reduce 4 8s, I could divide the 4 by 2 and the 8 by 2. I can divide all those things by 2. -2 divided by 2 would be -1. 2 divided by 2, so I've got plus or minus. 2 divided by 2 would be 1, but you would just write square root of 22 because the 1's not needed there. And then 6 divided by 2 is 3. So we actually have 2 answers. One of our answers is -1 plus the square root of 22 over 3. And the other answer is -1 minus the square root of 22 over 3. Okay, so those are the 2 answers. Please do not get extra stressed about this because I've got some tools that will help you with it. This one is a little bit easier because it doesn't have all this reducing a radical and reducing your fraction. So this one kind of goes a little bit faster. So with that being said, does anybody have a question about that one that we just worked? Like you don't understand how I came up with something, or because it was a little bit intense. If you don't want to ask me now and you want to ask me in lab, that's fine too. Okay. So A is in front of the x squared. That's a 1. We don't have anything there. B would be 5 because it's in front of x, and C would be 8. So we are using the same formula. X is equal to -b. Well, RB is 5 plus or minus the square root of b squared. So 5 squared minus 4 times A times C. A is 1 and C is 8. All over 2 times A, which is 1. Okay. Help with that part. Does everybody understand where we came up with how to plug those numbers in? And then remember from there, you just want to start reducing it slowly. So we know that that's -5 plus or minus. I could figure this out in the calculator. 5 squared minus 4 times 1 times 8. It's -7. We don't need that giant square root. And then over 2. All I can really do with this problem is I can break this -7 up into the square root of -1 times 7. And if you guys remember that the square root of -1 is an I, so I'm pulling that -1 out. The square root of 7 just doesn't simplify. There's no factors of 7. It's just 7 and 1 over 2. So I actually have 2, that's it. I have 2 answers here, -5 plus I times the square root of 7 over 2. And another answer is -5 minus I times the square root of 7 over 2. I think that when you work these problems on the computer, it likes for you to write it like this, to break that into 2 put that 2 under both of these. But you can use the plus or minus sign and type it in as 1. Does that make sense? You could type it in as -5/2 plus or minus I squared of 7 over 2. Instead of having to type 2 different things. Does that make sense? They have that plus or minus sign you can use. It might take this answer. I wouldn't have a problem with taking this answer. I just think there may be something funny about it, and it might want you to divide that fraction up. So questions about that? So here's the good news. Here is some directions about how to do it on the calculator. I'm going to make a separate video that I'm going to stop recording this one because I want to show you some how to do it on the calculator. So this is how you do this section by hand. I'm going to end 7.4 right here, and I'm going to start a new video